So the last one is going to be evaluate the integral over c of x plus y minus 3 ds on a circle of radius 2 from the point 2 comma 0 to the point 0 comma minus 2. So again, what we want to do is we want to figure out the curve so that I can evaluate it at the function. So what is r of t? Well, r of t is going to be, well, it's a circle clearly centered at 0, 0, but it's going to go from 2, 0 to 0 minus 2. And the way we do circles centered at the origin is we use, you know, r, let's do this in x and y real fast. So we really use parametrics to be able to do this. So r cosine of t, y is equal to r sine of t. Now we were using thetas before, but we tend to be using t's in these line integrals. So just, you know, assume t is the angle. All right. Now, if we did that, what we'd be talking about is, you know, a circle of radius 2, but, you know, this is going to be all r, so we'd have to define r. A lot of times we define it from like 0 to 2 and then from 0 to 2 pi. So if I did that, 0 less than or equal to r less than or equal to 2, we're actually filling in the circle. But I don't want the circle filled in. I want the radius just to be equal to 2. So that means these r's are going to be equal to 2. Now I don't want to go from 0 all the way back to 0 again. I really want just this part of the circle right here. So we know that we're going to go from 2 comma 0 to 0 comma minus 2. So that really means that our t values are going to be, which our angles are going to be from 0 all the way to 3 pi over 2. So if I write this in, you know, r of t format, this is going to be 2 cosine t I plus 2 sine t j, where 0 is less than or equal to t, which is less than or equal to 3 pi over 2. Now our curve, you know, our f of x comma y in this case is going to be, you know, x plus y minus 3. So I'm going to have to evaluate, you know, this function at this curve. So, you know, this is going to be, you know, your x, and this is going to be equal to y, which is going to go into here. Now I also know that in order to evaluate this, this is going to be equal to the integral over c of, you know, f evaluated at r of t multiplied by the magnitude of v of t dt. So I'm also going to have to find the derivative of r of t and then eventually its magnitude. So v of t is going to be equal to, well, the derivative of 2 cosine of t is minus 2 sine t I plus 2 cosine t j. And then the magnitude of this thing is going to be the square root of the sum of the squares of its components. So sine t squared plus 2 cosine t squared. So this is going to be equal to the square root of 4 times, you know, this is going to be sine squared t plus cosine squared t when you're done squaring. And so this is just going to be the square root of, you know, we know that's the Pythagorean theorem, which is going to be 1. So the square root of 4 is going to be equal to 2. So filling this out, we know that this is going to be the integral. Well, it goes from 0 to 3 pi over 2. Now f is going to be this function where, you know, the x component is going to be 2 cosine t. So this is going to be 2 cosine t is going to go here. The y is 2 sine t, so plus 2 sine t minus 3. Then we're still going to have to multiply this by the magnitude of the derivative, so times 2 dt. All right, so now I can pull out the 2 and integrate it. So pulling out that 2, 0 to, well, actually, let's integrate it while we're at it. So the integral of 2 cosine of t is going to be 2 sine t. The integral of 2 sine t is minus 2 cosine t minus 3t, evaluated from 0 to 3 pi over 2. So plugging these in, 2 times 2 sine 3 pi over 2 minus 2 cosine 3 pi over 2 minus 3 times 3 pi over 2. Then we're also going to have to subtract 2 times, you know, plugging in 0, 2 sine 0 minus 2 cosine 0 minus 3 times 0. All right, so let's figure out the values of these things. So we know that the sine of 3 pi over 2 is, you know, going to be on the unit circle here, but the sine is going to be the y coordinate, so this is going to be -1. The cosine is the x-coordinate, which is going to be equal to 0. Similar here, the sine of 0 is 0. Cosine of 0 is 1. So this will simplify to 2 times negative 1 is going to be minus 2. This is 0, so that whole thing is going to be gone. Minus 9 pi over 2. Minus 2 times, this was 0, so that whole thing is gone. Minus 2, and this also is 0. So we're done here. We're going to get minus 4 minus 18. Well, actually, the 2's will cancel. These 2's will cancel. So minus 9 pi plus 4. So this is going to be equal to negative 9 pi. And really what I was trying to do with line integrals is to show you, you know, how they look, the different types of parametric equations that we're going to use. We've seen what happens if it's in function form, so that you just let x equal t, so that you can do the trivial parametric. What happens if we're talking about straight lines? Well, how do you build straight lines in parametric form? And then finally, what do you do with circles? Well, with circles you use, you know, essentially polar transformation. So that's a good spot to end. So thanks for subscribing and staying to the end.